In this lesson, we're going to introduce the idea of a product rule. So a product rule, when you're doing the derivative, kind of has a very specific look to it. So you are asked to do the derivative of something, but that something end up being two independent functions multiplied together, right? So something like this. This is this term times this term. So we can apply the product rule to this. So the product rule looks like we do the derivative of the first one times the second plus the first times the derivative of the second. So derivative of the first times the second plus the first times the derivative of the second. And that is our process to doing the product rule. All right, so here's our situation. So we have this times this has a very much a product rule look to it. So we're going to be asked to do the derivative. We're really asked to find the derivative, the slope at 4, which means we need to do the derivative and then plug in the 4 to it. So let's do the derivative part first. So if we do our derivative, we're going to do the derivative of the first. So the derivative of x squared plus 4x plus 4 is going to be 2x plus 4 plus 4. So the derivative of the first times the second plus the first x squared plus 4x plus 4 times the derivative of the second. So that becomes 6x. All right, so it depends on what the directions are asking for. If it's just asking for what's the slope at 4, I could plug 4 into all of these and just kind of work through the math on it. Or it may ask specifically for the slope equation. So I'm going to anticipate or assume that they're going to ask for the actual slope equation every once in a while. So I want to go through that. And then once I get the full-on slope equation cleaned up, then I'll plug the 4 in. But it wouldn't matter. So it depends on what they're asking for, of how far you need to take this. So let me go ahead and clean this up, which means we're going to distribute this, distribute these, and then we'll combine our like terms. So we'll take the 2x distributed to both of those two. So that's going to be a 6x cubed plus 10x. Then 4 times that. So that's a 12x squared plus 20. And then we distribute this. We're distributing a 6x to all of those. So that's a 6x cubed plus a 24x squared plus 24x. One last little bit. So just in case the directions ask, we need to simplify it further than that. We need to clean it up, basically. We got a 12x cubed, and then 12x, so plus a 36x squared. Then let's see, our x's, we got a 10x and a 24x, so plus 34x plus 20. So if it is asking for specifically the slope equation, the derivative, then that's what we would be done with. So that would be it. Then second part of this is what's the slope at 4? And then that's us just plugging 4 into this. So we'd have a 12 times 4 cubed plus 36 times 4 squared plus 34 times 4 plus 20. All right, so I would be throwing that into a calculator. If I did that, it would get me a slope of 1,500. All right, so technically, though, this problem wasn't asking for the slope equation. So I could have left it in this version of the derivative. Like no matter what, I got to do the derivative. But I could have plugged the 4 in here, and I should get the exact same answer. If I do everything right, I will get the exact same answer. And one other thing is you don't actually have to do the product rule on this. If you would like to, you could distribute this whole thing out and create some sort of a 3x to the 4th type of equation and do the derivative from there, and you'll get this exact same thing. In fact, it'll get you right to this because you would be turning this into just a pure polynomial, and then that would just become this once you do the derivative. And then you can plug your 4 in. So sometimes you can avoid the product rule. Sometimes you can't. Probably the majority of the time you can't. But every once in a while, if you don't want to do it, distribute it all, take your derivative, and it'll get you right to it.